Good afternoon, everyone. Welcome to this session. In this session, I am going to discuss electron displacement effects or polar effects. So, what is the polar nature? Otherwise, what is polarity? Polarity is nothing but positive charge and negative charge are created in the molecule due to displacement of electrons. See, for example, here X and Y. This is a polar covalent bond. This is a polar covalent molecule. This is a polar covalent molecule. Okay. Here there are two electrons in this bond. There are two electrons in this bond. If Y atom has more electronegativity, if Y atom has more electronegativity, you know what is electronegativity? Electronegativity means it is a property of bonded atoms to attract shared pair of electrons towards itself. It is a property, otherwise the tendency of bonded atoms, not a single atom. Here X and Y, these two are present in the bond. They are bonded atoms. Among these two atoms, one of the atom can attract the shared pair of electrons towards itself. Which atom can accept that electron pair? The atom with more electronegativity can attract this electron pair towards one of the atom. Means here Y. So that at Y there is a increase in electron density, so that it will take a partially negative charge. At the same time, on X there is a decrease in electron density, therefore it will take a partially positive charge. So here partially negative charged pole is produced, here partially positive charge is produced. So that polarity is created due to displacement of this electron pair towards one side, which is nothing but polarity. So here for this polarity, here we have different effects. Polarity is created maybe due to inductive effect. This polarity created maybe due to electromagnetic effect or resonance effect or hyperconjugation effect. Today we will discuss these two in this session. First two, inductive effect and electromagnetic effect, today we will discuss. Okay. First, we will discuss about inductive effect. Inductive effect means it is polarity produced in a molecule, polarity produced in a molecule due to displacement of sigma electrons present in carbon chain. Polarity produced in a molecule due to displacement of sigma electrons present in carbon chain towards more electronegative, more electronegative atom from other atom is called as the inductive effect. What is inductive effect? Polarity produced in a molecule due to displacement of sigma electrons present in a carbon chain towards a more electronegative atom from other atom is nothing but inductive effect. See here we have two types of inductive effects. One is positive inductive effect, other one is negative inductive effect. Positive inductive effect and negative inductive effect. We have two types of inductive effects. One is positive inductive effect, other one is negative inductive effect. See, particularly for this inductive effect, what are the conditions? In examination, they may ask conditions with respect to definition. So polarity is created due to what? Here displacement of sigma electrons. Here the sigma electrons are required. Sigma electrons are required. Sigma electrons are required. Here it is a permanent effect. It is permanent effect. It is a permanent effect. Inductive effect is permanent effect. But one more thing is partial charges are produced here. Partial, otherwise fractional charge, not complete. Partial charges are obtained. Partial charges are obtained here. So because of partial charges, it is weak. It is weak effect. So what are the conditions? Otherwise, what are the features of inductive effect? It is due to sigma electron displacement. It arises due to sigma electron, and it is permanent effect. And here, due to displacement of these electrons, partial charges are obtained on the particular atoms. Carbon and other atom, partial charges are produced. Partial charges is represented by delta sign. Partial charge is represented with the delta sign. One partial positive charge, which means it is more. If we write double partial, so what it means? Double partial does not mean more. Double partial means it is less. Again, triple partial I am writing here. Please, if you increase the number of delta representations above that particular atom, that means that there is a decrease in that partial charge. It may be positive, it may be negative. Single partial negative indicates more negative charge is present on that particular atom. Double partial negative indicates somewhat partial negative charge decreases on that particular atom. And here one more important thing is here I am writing depends on inductive effect depends on distance. When distance increases, inductive effect decreases. When distance increases, inductive effect decreases. So here we can write like this expression. I effect is inversely proportional to distance in carbon chain. When distance increases, inductive effect decreases. Here, this inductive effect is up to third carbon. It is maximum up to third carbon. At fourth carbon, this is negligible. It is negligible. At fifth carbon, almost it is zero. At fifth carbon, it is the inductive effect is zero. So one more thing, what we have to remember is hydrogen atom. Hydrogen atom has zero inductive effect. We have to assume its inductive effect is zero. It has zero I effect. It has no minus I effect, no plus I effect. Its effect is zero. So this is the information. If you want to write, if you want to take this, please pause the video and you can take down afterwards. Okay. Then we'll go to next screen. This is about inductive effect features and how many types of inductive effects are written here. Then wait a minute. Now we'll discuss about positive inductive effect and also negative inductive effect. So here first one is plus I effect. Plus I effect. Here we have to compare electron attracting power or electron donating power with respect to hydrogen. Electron attracting power. Here the hydrogen has no attracting power, no donating power. Here the group which has more donating power than hydrogen are considered as plus I groups. All plus I groups all plus I groups are electron releasing groups. ERG. What it mean? ERG means electron releasing groups. Electron releasing group. Particularly all alkyl groups. All alkyl groups. All alkyl groups are ERG. Otherwise, all alkyl groups are having plus I nature. All alkyl groups are having plus I nature. And here, size of alkyl group, remember, size of alkyl group. Size of alkyl group is directly proportional to plus I nature. For example, if you take methyl, then ethyl, then propyl, CH2, CH2, CH3. So among these three, which has more plus I effect? More plus I effect is with respect to propyl group because of its size is more. It has more plus I effect than ethyl group. Ethyl group has more plus I effect than methyl group, and hydrogen has 0 plus I effect. Hydrogen has no electron donating nature or no electron attracting nature. So it has 0 effect compared to hydrogen. All the groups which have more capacity or more power to donate electrons to carbon chain are called as plus I effect. So plus I effect is nothing but what? Here in which the groups must be more attracting power than hydrogen. So the definition what we can write is the atom or group which has power, more power. Here listen, these are the electron releasing groups. Attracting means it must move towards that particular group side. So here I am writing clearly. Here, wait a minute. For plus I groups, I am writing the definition. The atom, here I am writing the atom or group. The atoms or group which have or which has less power, to attract electron. Which electron? Sigma electrons. Sigma electrons, the atom or group which has less power to attract sigma electrons than hydrogen atom are called plus I groups. Plus I groups, otherwise E or G groups, electron releasing groups. Plus I groups are electron releasing groups. And the phenomenon is called plus I effect. Plus I effect. Okay. Here, see, simple example I am taking. This is the carbon chain. 5 carbons are here, and here I am writing a group. This group. This group has less power, less attracting power. This group has less attracting power than hydrogen. Otherwise, we can say it has less electronegativity than this carbon. less electronegative group it is. So if it is less electronegative group, carbon can attract this sigma bond electrons towards itself. The carbon attracts the sigma bond electrons towards itself, so that at this group electron density decreases, so that this group will take partially positive charge, partially positive charge, and this carbon will take partially negative charge. And this is see, I means induction or inductive effect. So this negative charge, because of this negative charge, the adjacent carbon is somewhat induced. Here the effect is present on the adjacent carbon atoms. See here, this electron density now move towards one more next carbon. So here I am writing double partial negative charge. Similarly, here this electron and sigma electron density coming towards this carbon. So here we can write triple partial negative charge. So here almost it is somewhat, means it is very very less. At fourth carbon it is negligible. Just now I wrote it is negligible at fourth carbon, and at fifth carbon it is almost zero. It is 0 at fifth carbon. So this is the diagrammatic representation for plus psi effect. And we have some groups. Here I am writing order of plus psi groups. Order of plus psi groups I am writing. This we have to remember. Examination point of view, this order is very important. In examination, among these given groups or atoms, they give 3 or 4 groups in the question, and they ask the arrangement, means maybe increasing order of plus psi nature or decreasing order of plus psi nature. Otherwise, among the given 4 or 5 groups, which has more plus psi nature, which has less plus psi nature. So here I am writing that order, you have to remember. So generally, just now I told all alkyl groups have more plus psi nature, or alkyl groups are electron donating groups. But here first group what I am writing is O minus. On oxygen, if negative charge is there, it is more and more plus psi nature containing group. Then after COO minus, this is carboxylate ion. Then it has more inductive plus psi inductive effect than tertiary. Tertiary means CH3, C, here CH3, CH3 is the group. This is the tertiary butyl. Tertiary 3 degree. Tertiary butyl I am writing here. Tertiary butyl group. Then secondary. Secondary means CH3, here CH, CH3. This group. This is secondary propyl we can say. Secondary propyl. Then after we can say primary CH3, CH2. This much only. This group. It has it is primary. Then least here methyl group. Then after here only I am writing after methyl group deuterium. Then last one is hydrogen. Hydrogen has least, which is nothing but it has 0 inductive effect. One more time I am giving here O minus, then COO minus, and tertiary butyl group, then secondary propyl group, then it is primary otherwise ethyl group, then methyl group, then deuterium, D means deuterium, and next one is hydrogen. So all these are electron releasing groups, otherwise plus psi groups. All plus psi groups are nothing but electron releasing groups. So here plus psi effect is nothing but the atom or group which has less power to attract sigma electrons towards itself, or sigma electrons than hydrogen atom is nothing but plus psi group, and the phenomenon involved in that process is plus psi effect. So this is the information. Then next about minus psi effect. This is about plus psi effect. Then minus psi effect. Important thing is this one. Examination point of view for NEET aspirants, otherwise any objective related examination who attends, for them this is very important. From this they give 3 or 4, and among those 3 or 4 they ask the order, ascending order, of plus I nature or descending order of plus I nature, otherwise which has more plus I nature, which has less plus I nature. Okay, remember this. Then about minus I effect. Same definition for minus I group also. Here comparison with hydrogen. In plus I effect, electrons are moving away from the group. Remember that. In plus I effect, electrons, sigma electrons are moving away from the group. In minus I effect, electrons are moving towards the group. See here, second one is minus I effect. Minus I effect. Here, the atom or group, which has more power, more attracting power, more attracting power, more attracting power. The atom or group which has more attracting power than hydrogen. The atom or group which has more attracting power of sigma electrons. Attracting power of, you can write here, sigma electrons than hydrogen are called plus I groups, and the phenomenon involved is called plus I. The phenomenon involved is called as minus I effect. Here minus I effect is nothing but the atom or group which has more attracting power of sigma electrons than hydrogen are called minus I groups, and the phenomenon involved is called minus I effect. Okay, and here schematic or representation of writing like this. 5 carbons I am taking here. Here I am taking group. This group has more attracting nature than hydrogen atom. Means here attracting nature towards what? Sigma electrons. That indicates what? It has more electronegativity. It has more electronegativity. More electronegativity means these sigma electrons are now transferred to the group here, so that it will get partially negative charge. So carbon of the carbon chain will take partially positive charge. So to compensate this positive charge from adjacent carbon, this carbon attract electrons, sigma electrons. So here double partial positive charge are written. Similarly here the effect is negligible at fourth carbon, and at fifth carbon it is almost 0 it is. So this is the schematic representation, and here also we should know order. Many groups we have here, order of minus I groups. One thing you can observe here, in this thing is electron. See this migration arrow mark you can observe. This arrow mark means migration or displacement of the sigma electrons towards group. If it is towards group, then we can say minus I. Otherwise, in the carbon chain, if you observe positive partial charge, then it is minus I. If you observe the reverse in the sense here group if takes partially positive charge, and carbon chain if takes partially negative charge. Otherwise, here sigma electron displacement is away from the group. If it is moving towards that side, then we can say it is plus I. Minus I and plus I, there is a difference. Sigma electrons movement is towards chain, otherwise away from the group is nothing but plus I. Sigma electrons the displacement is if towards group, then it is minus I. Then order of plus minus I groups, you have to know many groups we have. Here I am writing one by one. See first here R3N R3N plus. This group has more and more minus I nature than R2S plus. Then NH3 plus, it is ammonium. Then after we can write NO2, SO2R, NO2 group, nitro group. Then SO2R, the sulfonyl, alkyl sulfonyl group. Then cyanide. Then carboxylic acid. Then after carboxylic acid we can write fluorine, chlorine, bromine. Here fluoride. Then here I am writing after fluorine, here chlorine means chloride. Then bromine I am writing here. Then iodine. Then after iodine we have aryl oxy, OAR, otherwise phenoxy we can say. Then after we have COOR, it is ester. Then after ester we have alkoxy, means ether. After alkoxy we have keto type, C double bond O. Here we can write R. Then thiol, SH. Then SR, alkyl ether it is. Then after SR we have hydroxy group. After hydroxy we have NH2 amine. Then after amine we have alkynyl, means C triple bond Cr. After alkynyl then phenyl, otherwise aryl. Then lastly we have alkenyl. Alkenyl means CH double bond CH2, otherwise here R I am getting alkyl. So these are different groups. So we have to remember here by head. Here R3N, R2S, NH3 plus, NO2, SO2R, CN, COH, F, Cl, Br, iodine, OAR, COOR, OR, C double bond OR, SH, SR, OH, NH2, C triple bond Cr, AR, then CH double bond CHR. These are the different groups. So in previous examination papers I have seen this question. In previous examination papers I have seen this question. From this they give 4 or 5. Here many are there. Among these they choose only 4 or 5 and they throw into question. And they ask right, what is the order of increasing minus I nature of these groups or decreasing minus I nature of these groups. Otherwise among the given, which has more minus I nature and which has less minus I nature. So this order, this minus I nature is directly proportional to electronegativity only. Electronegativity only. More electronegative atoms generally takes more minus I nature. Less electronegative atoms can take less minus I nature. So all these groups we have to remember. Here I written group no. Here among these anyone you can write here. So that all the electrons which are present in carbon chain, which are sigma electrons, are transferred towards the group side. So that when sigma electrons are displaced towards the group means it is minus side. If sigma electrons are move away from the group means it is plus side. So these are the different groups. You can take these. Then we have some applications. Applications of inductive effect examination point of view. Applications are very important. Different applications we have with respect to reactivity, then stability. We can explain stability of some compounds. Reactivity also. Reactivity and stability, these two are inversely proportional. Then acidic nature of aliphatic carboxylic acids, and basic nature of amines, and even dipole moments also we can explain by using inductive effect concept. So first thing is reactivity in applications. That is uses applications of inductive effect. Applications of inductive effect. Applications of inductive effect. In this first reactivity. Reactivity is directly proportional to inductive effect. See, for example, here I am taking CH4 and CH3Cl. CH3Cl means it is methyl chloride. This is methane, This is methane, and this is methyl chloride. Methane and methyl chloride. So methane is less reactive than methyl chloride. Why means here because of more electronegative chlorine, here inductive effect is present. Here inductive effect is present. Here no I effect. No I effect. Because of no I effect, methane is less reactive than methyl chloride. Here see these electrons, these sigma electrons are moving towards chlorine. Chlorine will take partially negative charge and carbon will take partially positive charge. So that here the attacking reagent is negative charged group, negatively charged, which is nothing but nucleophile, which is nothing but nucleophile. Negatively charged groups are nothing but nucleophiles. So that here the nucleophile attack takes place. So these are nothing but nucleophilic reactions. So that reactivity of the compounds are more in which inductive effect is present. The reactivity of the compounds are less if there is no inductive effect. So methane is less reactive than methyl chloride. Why means in methane no inductive effect. In methyl chloride there is an inductive effect. Similarly here reactivity of different alkyl halide separating. Different alkyl halide separating here. First just now we have discussed tertiary. This is a tertiary compound. Tertiary alkyl halide is it is having more reactivity than secondary. CH3, CH, CH3 here X. Then after primary CH3, CH2 X. Then CH3 X. So what is the reason for this? What is the reason for this? This is tertiary butyl halide. It's called as tertiary butyl halide. This is secondary propyl. Otherwise, isopropyl also we can write. It is secondary and also iso. Isopropyl. Isopropyl halide. Then this is ethyl halide. Ethyl halide. Then this is methyl halide. This is methyl halide. See here, reactivity of tertiary butyl halide is more than isopropyl halide, than ethyl halide and methyl halide. So what is the reason? If you move from left to right, inductive effect decreases. Otherwise, inductive effect, plus inductive effect decreases. That is the reason. So more alkyl groups are present here. More alkyl groups means more inductive effect. Here see, from here there is a electron. This is the electron, sigma electron move towards this carbon. Here also sigma electrons are moved towards this carbon. Here also sigma electrons are moved towards this carbon. Now this carbon is more electron denser. And here X it is more electronegative. Here also more electrons are present. Here also more electrons. Here also more electrons. If two more electrons or electron density containing atoms are present adjacent to each other, then there exists some repulsion, so that it can break this bond easily. so that X can be easily eliminated, and one more group may come here to attack this carbon atom. So that is nothing but reactivity only. But here only two sigma electrons from this methyl group and this methyl group are attracting towards or move towards this carbon. Compared to this carbon, this is less electron denser. Here X is also electron density is more electron into atom. So this is also more negative, this is also more negative now. Therefore, between two more negative atoms there exists repulsion, so that there is a chance to break this bond. So here it is very easy to cleave, here it is somewhat less easy to cleave. That means here it is more and more reactive, then reactivity decreases from here to here, here to methyl halide. In methyl halide, there is only one methyl group is present, so that there is no more inductive effect. So from this tertiary methyl halide to methyl halide, from left to right here, from for this one, from left to right, inductive effect decreases. Therefore, reactivity decreases. Similarly, we can explain stability of carbocations by using inductive effect. So in I think whenever any charged species is produced, charged species means maybe on carbon positive charge or maybe on carbon negative charge, maybe on carbon positive charge or negative charge is produced. The positive charge produced if compensate more means it must be decreased. Here on this carbon there is a negative charge. If the negative charge is decreased, otherwise compensated by any other way, then only it will get stability. Means it must move towards zero side, zero charge. Here also it must move towards zero charge. So to move this positive charge towards zero, here it requires electrons. Thus positiveness is compensated by negativeness, so that electrons are moving towards carbon side. This positive charge which is present on carbon must be compensated. Similarly, here electrons are more, so electrons must move away from the carbon atom. This electron pair here, more electron density is present on this carbon. So how we can decrease this electron density? If we remove somewhat negative charge above this carbon atom, then it will get stability. So here the adjacent groups must be electron taking groups, otherwise minus I groups means electron withdrawing groups. If electrons are moving toward this side, then it will get zero charge, or charge is decreased from 1 to 0. Here the charge is decreased from 1 to 0 when electrons are moving towards carbon. So here this is important. Whenever any charged species is produced, it may be carbocation, it may be carbene anion. So charge present on the particular carbon must be decreased or nullified or compensated, then only it will get stability. So same thing here by using inductive effect we can expect stability of carbocations and writing here. One more application, stability of carbocations. Stability of carbocations. Here carbon, here I am writing positive charge, this carbocation, here this carbon is attached to 3 methyl groups. This is tertiary butyl carbocation. You can say it is tertiary butyl carbocation, C plus M. It is tertiary butyl carbocation. Then CH3, then C, here CH3, here H. This is a secondary carbocation, otherwise secondary propyl we can say, or isopropyl, secondary propyl carbocation. Similarly, here CH3, CH2 plus, this is ethyl, this is ethyl carbocation. Then after here I am writing methyl, just CH3 plus carbocation, methyl carbocation. Among all these, which is more stable means tertiary butyl carbocation is more and more stable than this one, than ethyl group, than methyl group. Why it is so? See, just now I told the positive charge produced on carbon must be more compensated by these 3 methyl groups. So from 3 sides, sigma electrons are transferred to this carbon, so that here more positive charge is compensated, and this positiveness almost becomes 0, so that it is more stable. Then here also same thing, but the number of electrons, if we compare with the tertiary butyl, here only 2 methyl groups are giving the electrons to this carbon plus, so that here somewhat compensated, but not this much. Here more compensation, here less compensation, very less compensation, very less compensation. Here also due to decrease, due to decrease in plus psi effect, due to decrease in plus psi effect, stability of carbocation decreases from left to right, from tertiary butyl carbocation to secondary propyl to ethyl carbocation to here this methyl carbocation, this methyl carbocation. Okay, this is the one more application. Then for carbon ions, it is reverse. It is carbon ions, it is reverse. So tertiary butyl carbon ion, tertiary secondary propyl carbon ion, and ethyl carbon ion, and methyl carbon ion, if you write. See here I am writing stability of carbocations explained by one more polar effect, that is hyperconjugation. There also we will discuss. Here by using inductive effect also we can explain stability of carbocations. Stability of carbon ions means C minus. Same thing here I am writing CH3, CH3, here CH3 minus I am writing CH3. This tertiary butyl carbon ion, See, this is very less stable. This carbon ion is very less stable. Why it is very less stable? Because the negative charge is ground here. Because the alkyl groups are generally electron releasing groups. So whenever electrons are released to this negative charged carbon, here some more electron density, means negativeness increases. Some more negativeness increases, so that it will get more and more instability. Then this one CH3, CH, here CH3, then negative charge on writing. Then CH3, CH2, negative charge. Then after CH3, negative. Methyl carbon ion is more stable than ethyl carbon ion. Ethyl carbon ion is more stable than isopropyl carbon ion. Okay, next about dipole moments. So because of inductive effect, sometimes dipole moments may increase, sometimes dipole moments may decrease. You know, dipole moment means it is represented by mu sign. Dipole moment, it is represented with mu sign. It is called delta into L. It is nothing but charge on particular atom, and L is nothing but distance between two atoms. For example, if you take HCl, H will take negative charge, hydrogen will take positive charge. So this delta is nothing but charge on one of the poles, and L is nothing but distance between these two atoms, chlorine and also hydrogen. So let it be. Here dipole moments, generally, you know, dipole moment, as per general concept, dipole moment is directly proportional to difference in electronegativity. If electronegativity is more, then we have inductive effect also more. All these are one-to-one relation, inductive effect here. Dipole moment is directly proportional to electronegativity difference. If electronegativity is more, that atom can attract sigma electrons towards itself, so that inductive effect also we can expect more. See, from the same concept, here I am writing CH3 iodine, CH3I, and CH3 Br, and CH3 Cl. So among these we can expect, based on this, here iodine electronegativity is less than bromine, than chlorine. Chlorine is having more electronegativity than bromine, than iodine. Adjacent group is methyl group, it is common for all. So that here dipole moment is more. Dipole moment is more for methyl chloride than methyl bromide, than methyl iodide. As per experimental findings, the again values also 1.64 D dipole moment unit is D by unit. 1.64 D is for methyl iodide. For methyl bromide, 1.79 D. 1.79 D. For methyl chloride, it is 1.89 D. 1.89 D. Here one exception is there. Methyl fluoride also we can take because of fluorine's very small size, because of its very small size, exceptionally it is having very small size. Because of its small size, the length between fluorine and methyl group is less. Because of that reason, if length is less, then dipole moment also will be less. So that concept you have to apply for methyl fluoride. So here in this methyl fluoride will insert between these two. CH3, F I am writing here. Here it has 1.85 D. So it is in between methyl bromide and methyl chloride. This is the exceptional case. It is important. Generally, what we can expect? Lastly, here we can write methyl fluoride, because here electronegative difference is less. Here somewhat more. Here somewhat more. Here electronegativity is more and more. But at the same time, because of its very small size, the distance between methyl group and fluorine is also very less. If distance is less, if you remove this delta, which is constant, directly proportional to L. If distance is less, dipole moment also less. This concept we have to apply for methyl fluoride. So that what is the order now? Order is like this. After this, we can write methyl fluoride, then methyl chloride. Among all alkyl halides, methyl halides means methyl iodide, methyl bromide, methyl fluoride, methyl chloride, which is having more dipole moment means we can say methyl chloride, not methyl fluoride, because of its small size. Fluorine small size, it has 1.85 D. Here approximately 1.89 D. So this is also one of the applications of inductive effect. Then order of acidic nature. This is important. Order of acidic nature. Order of acidic nature of aliphatic carboxylic acids. Straight chain, not ring. Aliphatic carboxylic acids. Aliphatic carboxylic acids. See, for this we have to remember the relation. What relation? Here plus I effect. Plus I effect, and here minus I effect. Minus I effect is directly proportional to acidity or acidic nature. Plus I effect is inversely proportional to acidic nature. This we have to remember. Why it is so, we'll discuss. By taking examples, we'll discuss about plus I effect is the inversely proportional to acidic nature. When plus I effect increases, acidic nature decreases. When minus I nature increases, acidic nature increases. So here I'll give examples. See here the first example I am taking like this. First of all, how we can expect acidic nature that I will discuss. Carboxylic acid means C double bond OH. This is carboxylic acid. See, if any compound you can take, not only this carboxylic acid, any compound, if that produces H plus ions very easily means it is strong acid. If it produces it is somewhat difficult means hydrogen production of this hydrogen plus ion is somewhat difficult means it is weak. So when it is difficult to release this hydrogen, when it is easy to release this hydrogen means depends on this oxygen. Depends on this oxygen. If this oxygen holds hydrogen very tightly, means it is difficult to release. If it does not hold hydrogen tightly, then it is easy to release. When it can hold hydrogen tightly means when electron density increases. Above arrow indicates the increase. When electron density increases on oxygen, then oxygen can hold hydrogen tightly. So that it is difficult to release H plus. Therefore, we can say it is a weak acid. You can say it is weak acid. When on oxygen electron density increases, when electron releasing groups are present, E or G groups are present. When electron releasing groups are present on carboxylic acid framework, then these electrons shifted towards the carboxylic acid framework. Through this, oxygen gets more electron density. So that ERG is nothing but what? It is nothing but plus I. So that plus I effect, it is more. When plus I effect is more, then acidic nature will be less. So why it is so means whenever plus I nature containing groups are attached to carboxylic acid framework, they can donate electrons, they can release electrons to carboxylic acid framework, and electron density increases on this oxygen. Therefore, this oxygen can hold hydrogen tightly. Therefore, it is difficult to release H plus ion, so that it becomes weak. Similarly, here C double bond O, OH I am writing here, C double bond OH. If EWG, what do it mean? EWG? EWG is nothing but electron withdrawing groups. Electron withdrawing means these can accept electrons from carboxylic acid framework to itself. Whenever the electron density shifted towards electron withdrawing group, then electron density decreases on carboxylic acid framework and oxygen also. So here on this oxygen, electron density decreases. Electron density decreases. When electron density decreases, this oxygen cannot hold hydrogen tightly. When electron density decreases on O, oxygen of carboxylic acid framework, then that oxygen cannot hold hydrogen tightly. That means easy to release H plus ion. Easy to release H plus ion in the sense it is a strong acid. This concept first of all you should know. This is the carboxylic acid. This is also carboxylic acid. But thing is ERG, electron releasing groups are present on carboxylic acid framework. Here electron withdrawing groups are present. Means these are nothing but minus I groups. All minus I groups are electron withdrawing groups. All plus I groups are electron releasing groups. And hydrogen has no electron withdrawing nature and no electron releasing nature. It has zero inductive effect. So here see, in the presence of minus I groups or EWG, what happens? Acidic nature increases. It is easy to release hydrogen, means it is strong. Means acidic nature increases. Here weak means acidic nature decreases. So now we'll give some examples. So particularly order related questions they ask. All the order related questions are very, very important. Here I am writing order first, then after I'll explain in that order only why it is so. First here I am writing CH3 COOH. This is acetic acid. Before that I am writing here H C double bond O OH. So this is formic acid. This is formic acid. This is acetic acid. Among these two, formic acid is stronger. Why? See here methyl groups are present. Methyl group is nothing but electron releasing group. So electrons are moving towards the carboxylic acid framework and oxygen gets more electron density. So that oxygen can hold hydrogen tightly so that it is difficult to lose. So this is weak. Difficult to lose means it is weak. Then some more already just now I told, when size of alkyl group increases, inductive effect also increases, plus I effect also increases. So that in the same way here I am writing CH3 CH2 C double bond OH. Then CH3 CH2, one more alkyl group I am adding here, C double bond OH. So this is very weak because here 2 carbons containing alkyl group, here 3 carbons containing alkyl group, like that we can write 4 carbons containing alkyl group. Whenever alkyl group length increases, acidic nature decreases, because whenever length of alkyl group or size of alkyl group increases, plus sign nature increases. When plus sign nature increases, that plus sign group can donate its electrons, sigma electrons, to carboxylic acid framework. The same time, on oxygen electron density increases, so that oxygen can hold hydrogen tightly, but it will not happen in formic acid because it has no inductive effect, so that it will not donate any electrons to carboxylic acid framework. There is no any increase in electron density, so that this is the order of acidic nature. This is first example. This is the first example. Next, one more example I am giving here. See here, I am taking F CH2 C double bond OH. See what is happening here? Fluoroacetic acid. Then here I am writing chloroacetic acid. Then you can expect now bromoacetic acid. Then iodoacetic acid. Iodoacetic acid. See here, fluoro is the more and more electronegative atom, so that here the more minus I effect, so that more number of electrons are transferred to group, that is fluorine, so that on oxygen electron density decreases. Whenever an oxygen electron density decreases, it cannot hold hydrogen tightly, so that it is easy to release, so that this is stronger acid. Similarly, chlorine, bromine and iodine. Here what is happening in this first example? Plus sign nature increases. That is the reason for why acidic nature decreases from left to right in these groups. Here minus I nature decreases from left to right, so that here acidic nature decreases. Okay, next one more example I give. Then about basic nature of amines in next session we will discuss. Almost time is 1 hour. So one more example I'll give for acidic nature. Then after I'll stop the class. Then in next session, I say basic nature of amines and electromeric effect we will discuss. So here one more example is CCl3 C double bond OH I'm writing. Trichloroacetic acid. Then Cl2, here I'm writing CH Cl2 C double bond OH. It is the dichloroacetic acid. Then chloro CH2. Otherwise we can write like this also, CH2 Cl C double bond OH. This is chloroacetic acid. See what is happening here? 3 chloro groups are present. So that here more minus I nature. When number of minus I groups or more electronegative groups are present more, then there should be more minus I nature. So that here more and more number of electrons are transferred toward this side, group side, and oxygen electron density decreases. So it is very easy to release that hydrogen. So it is very strong. Here only 2 chlorines, so the minus I nature is less. Here only 1 chlorine, so minus I nature is very less. So this is about inductive effect, plus I effect, and minus I effect also I given here. In next session we will discuss about basic nature and electromeric effect. So stay home and stay safe. Thank you.